applications of integration. And the first section is so only 5.1 and 5.7. 5.1 deals with what it's called consumer and producer surplus. And 5.7 deals with differential equations. So let's start with 5.1. We talked about this some time ago about demand and supply. So this is an example of a demand function, demand of X. This is the price, X, and this is the number of units, or D of X. Why does this function look like this? Or it's a decreasing function, because the higher the price, the lower the demand. Everyone can purchase a home of a certain price, or almost everyone, I would say. But if the price goes to millions, not everyone can afford a home that is in the millions of dollars, right? So this is a decreasing function. Let's say we are purchasing some commodity for this price. I'm just making up a number. Let's say it's $3 per unit. And when we plug in 3 in the function for this price, this is the number of units we want to buy. So we are ready to buy at price of 3. Let's say I'm making up a number, 10 units. So if the price is 3, we're willing to buy 10 units of that product. Okay, so this area right here, between the demand function and the y coordinate of this point, which is D of 3, or 10 if you want, is called the consumer surplus. This is the added value. If we purchase here at this price, let's say $10, we have more added value, because the area on top of this, I don't want to put more stuff on the graph. So the area on top of this horizontal line will be bigger. So if we want to pay more, if we're willing to pay more, we will get more utility. We're going to get extra in the form of this area, in dollars, of course. So now, how do I determine the consumer surplus? CS, consumer surplus. How do I find it? I will determine this area, which I know how. So the consumer surplus will be the integral from 0 to 3 in my example, from D of X dx, but that's not the consumer surplus. I have to subtract the area of this rectangle. So I subtract 3 times 10. This is how I get, this is the formula for the consumer surplus for any price that I'm happy with and the number of units that I would like to get. So now let's take a look at the producer surplus. So the producer curve, I'm sorry, the production, or not the demand, the supplies, that was the word I was looking for. The supply curve, of course, is different. So the supply curve is, the higher the price, the more they will love to produce and sell because they make more profit. So let's suppose again, I have, let's say here, the same idea. I'm just going to pick a number. Let's say the price of $10. This is the number of units. I'm going to say 7. And this is the point in question. And this piece now, above the curve, but not beyond the rectangle, is what is called the producer surplus. Is what they get extra for selling us at $10 per unit, 7 units. How do I determine the producer surplus? It's the other way. From the area of the rectangle, which will be 10 times 7 in my example, I subtract the area under the graph, the area between 0 and 10, the integral from 0 to 10, from s of x dx. And this will be that added value for them, producing and selling us at $10 per unit, 7 units. One more idea, and then we can apply these in different situations, is this. And we talked about the equilibrium point a long time ago. What is the equilibrium point? Is when the demand and the supply, everyone is happy. So this is the equilibrium point. So at this price and number of units, I'm going to just pick numbers again, let's say 3 and 5. So the equilibrium point, which has coordinates 3 price in dollars and 5 units, it could be 5,000, it could be anything, 5,000 units. So at this point, everyone is happy. The consumer, the demand, the consumer is happy to purchase at 3 for the equilibrium point 5, and the producer is happy to produce and sell 5 at that price. Now, if we deviate from here, left and right, one or the other loses. But at 3,5, everyone is happy. Okay. Now, we will be asked to determine, for the equilibrium point, we will be asked to determine the producer surplus. No problem. This is the area. Producer surplus. And we will also be asked to determine the consumer surplus, which is this area. And we know how we determine them. So let's see, I'm on page 454. Anyone, any questions? Let me ask you this, and I'll sip some water. Any questions for me so far? Any questions, anyone? Okay, so in that case, on page 545, I'd like to practice this. I don't want to jump into the equilibrium point just yet because I like to look at another problem before we look at the equilibrium point. Although from 1 through 14, I do not see any problem. Consumer and then the dollars for producers will accept as find the equilibrium point. Okay, find the consumer surplus. So let's start with that then, because it's the first set of problems. So in these problems, we're asked, number 1, part A, to find the equilibrium point. In part B, we're asked to find the consumer surplus. at the equilibrium point, and the producer surplus at the equilibrium point. Fine. Does anyone want to choose anything from 1 through 14? Or I will. 11. Where are you, 11? I see it. Okay, so D of X, which is the demand, 1800 divided by the square root of X plus 1, and the supply, S of X, 2 times the square root of X plus 1. Okay, so in part A, we're asked to find the equilibrium point. Well, how do I find the equilibrium point? I set these two functions equal to each other. Okay. So D of X is the same with S of X. And I have 1800 divided by the square root of X plus 1 equals twice the square root of X plus 1. Well, I'm giving you a hint. And this is like a proportion, right? I will cross multiply. This times this equals this times this. And let's see what we get. So we get 1800 equals twice X plus 1. The square root of X plus 1 times the square root of X plus 1 is X plus 1. Well, you could say it's the absolute value of X plus 1, but everything here has to be positive. We cannot produce or sell or buy -3 units or pay -$5. So then from here I have 1800. I would like to divide by 2. So this is 900 equals X plus 1. So then X is $8.99 per unit. So the equilibrium point is $8.99, comma. I have to go back and replace in any of the functions. It doesn't matter in which one. Let's say D of $8.99. Doesn't matter. So I have 1800. $8.99 plus 1 will be 900. The square root of 900 is 30. So 1800 divided by 30, and I get 60. This is in dollars, and this is in units. So we determine the equilibrium point. Fine. Moving on to part B. In part B, I'm asked to find the consumer surplus at the equilibrium point, which is the area under the graph of dx, subtract, now this is my $8.99. Why do I need that graph? I don't. If it doesn't start at 0, I have difficulties with that because we don't know how to integrate improper integrals. So there is no asymptote here or anything like that. So the area is $8.99 times 60. And this is the consumer surplus. So the consumer surplus will be the entire area, the integral from 0 to $8.99 from the demand function, which is this one, 1800 divided by the square root of X plus 1, of course dx, minus, and my calculator used to be somewhere here. I'm lazy. So 899 multiplied by 60 is 53940. Okay, so let's determine this. In order to determine the integral, find the definite integral between from 0 to 899 of this function. First of all, I will move 1800 outside. I will denote by t x plus 1. I will find dt, which nice is just dx. I will change the limits of integration when x is 0, t is 1. When x is 899, t is 900. And dx will be replaced by dt, and I do have 1 over the square root of t, or t to negative 1/2, minus 53,940. Let's stop for a moment and see if you have any questions so far.